Assalamualaikum and good afternoon. So we are from group 2. Our experiment is flow over immersed body and boundary layer theory. So this is our group member. My name is Lani bin Muhammad Zanasi, MA18283. I will start the introduction. So this experiment is used to determine the speed distribution of a flat plate. Next, to identify its boundary layer thickness for rough and smooth surface subject to longitudinal flux. Then the drag and lift force applied on a symmetric aerofoil at various points of attack have been measured by means of a comprehensive measurement technique for fluid flow. Then we use the formula for calculation such as speed and number for Reynolds. The Reynolds was used in order to understand the fluctuation between the turbulent and laminar flux. Last from me, the objective. The objective is to design complete measurement technique for fluid flow and measure the drag and lift force applied on a symmetric aerofoil at different angles of attack. Next, to determine the velocity distribution for flat plate. Last but not least, to determine the boundary layer of thickness of a flat plate subjected to longitudinal flow for rough and smooth surface. So that's all from me. I will pass to our next presenter. Thank you.
For the equipments and material for the experiment, first we need mobile rolling frame at number 1 with bench top at number 2. Then radial fan 0.55 kilowatt at number 3. Switch box at number 4 and drawer for small parts at number 5. So for air intake pipe at number 6 with throttle valve at number 7 and thermometer at number 8. So for number 9, rectifier, and number 10, removable nozzle. So number 11, funnel for air inlet, and for number 12, off air pipe, and number 13, fixture for 16-volt water pressure gauge, and number 15, measurement glands for measuring tubes. For experiment 1, which is flow patterns of symmetric aerofoil at different angle of attack. So the experiment setup is shown in the figure. So the aerofoil model is attached and screwed to the airflow bench. The first angle attack at 0 degree is selected to start the experiment, and the switch is turned on. Next, the smoke controller is pressed to emit smoke, and the radial fan is allowed to move. And then the picture of the flow is taken. Then the reading is recorded and tabulated. Then the radial fan speed controller is increased, and lastly the experiment is repeated for angle attack of 30 degree, 45 degree and 60 degree. For experiment 2, flow over flat plate. The experiment is set up as shown in the figure. So the smooth surface plate is inserted into the airflow bench, and then the distance of 10 mm is taken as first value. The pitted tube is connected to the vernier caliper, and then the pitted tube is first touched to the surface of the flat plate as the first data. And then the radial fan is turned on and any data are recorded and tabulated. The distance of the plate is increased by 10 mm to 30 mm, while the pitot tube distance from the surface of flat plate is increased by 2 mm and 2 mm to 6 mm. And lastly, the experiment is repeated for the rough surface.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Amir Hakim bin Alias, and I will continue our presentation about the result and discussion. We have two experiments, so I will explain the experiment 1, which is flow pattern of symmetric aerofoil at different angle of attack, flow over immersed body. So we start with the angle of attack 0 degree. We need to find the drag force and lift force by using the formula FD or FL equal to CD or CL times 1/2 rho velocity squared and area, which is the area of aerofoil. So we can plot the graph with the which is the lift force against fan speed. As you can see, based on the graph, lift force and drag force against fan speed. The fan speed increase and the drag and lift force also increase. The bigger the attack angle, the higher the drag and lift force. The drag force is proportional to some function of the velocity of the object in that fluid. Lift is proportional to the density of the air and approximately proportional to the square of the flow speed. Lift also depends on the size of the wind, being generally proportional to the wind area projected in the lift direction. Next, sketch the streamlines of the aerofoil at different inclination angles with separation and stagnation points clearly labeled. We have three angle of attack, which is 0 degree, 30 degree and 45 degree. As you can see, the angle are different. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Alif Lukman, and now I will continue to present experiment 2. So from the experiment 2, from the data we obtained and from the graph, we can see that if the boundary layer thickness increase, the height recorded will decrease. This is due to the increase in boundary layer thickness that will cause the pressure in fluid flows from pitot tube to manometer become higher, and this will further push the fluid in the manometer, thus lowering the height in manometer. Next, we proceed with velocity. To calculate the velocity, we use the formula velocity is equal to square root 2g delta h, which is delta h is h null minus h. And based on the graph, we can see if the boundary layer thickness increase, the velocity of the fluid increase as well. By comparing from the aspect of difference in the distance of the plate or length of the plate exposed, a smaller distance produce a lower velocity. When the length of the plate is short, the boundary layer will become thin. Hence, the velocity will be lower. The thickness of the boundary layer increase with the length of the plate where the fluid flows by. Next, we continue with Reynolds number. We also can calculate Reynolds number from the velocity using a formula, Reynolds number is equal to rho VL divided by mu. From the graph, we can see that we found that the thicker the boundary layer, the Reynolds number increase due to the increase in velocity. From the equation, hence there are flows in lamina and transition region. Reading the data according to the thickness of boundary layer, we can only observe a slight difference in Reynolds number with the increasing boundary layer thickness. The range of distance of plate is sufficient to show lamina flow, which is below than 2300. Thank you.
Thank you, my friends. For the conclusion, we successfully done this experiment virtually. In this experiment, we have finished design a complete measurement technique for fluid flow and measure the drag and lift forces applied on a symmetrical aerofoil at different angle of attack. We also have determined the velocity distribution for flat plate. The boundary layer on a plate is generally affected by some factors, such as speed of flowing fluid, Reynolds number, and the roughness of the plate. If the speed of the flowing fluid is increased, the Reynolds number will increase. And lastly, based on experiment results, we have determined the boundary layer thickness of a plate, subjected to longitudinal flow for rough and smooth surface, which is the speed of the flowing fluid is much higher for smooth surface plate compared with the rough surface plate. Thank you.